So in this question, we're going to try and convert these two recurring decimals into fractions. Now here you'll see the recurring decimal is the second digit in this one, so this 2 doesn't recur. And here the third digit is the recurring decimal. This 58 is not recurring. So this one here will be equivalent to 0.58333, so on. And this one 0.2333, and so on. Okay, so what we want to try and do now is get this recurring decimal on its own, this side of the decimal point, and these numbers on this side. So let's set our x this time to 0.23 recurring, which is the same as this. So that would also be the same as our x. Okay, so if we multiply by 10, let's go through this one step at a time. We have 2.3 recurring. That we're multiplying that by 10. So that's what we've got there. So now what we want to do is see what else we can do here to try and get this exposed so we could subtract something. So what about if we multiply by 10 again? So 100x would equal 3, so that's 23.3 recurring. So now you'll see now our 100x is 23.3 recurring, so 23.3 recurring, and our 10x is 2.3 recurring. So now if we subtract these, you'll see now these will cancel out and we're left with 21. So that's ideally what we want. We want to cancel out some of our recurring fractions. So let's do that. So here I've got 100x, which would be my 23.3 recurring, and subtract my 10x, which is the 2.3 recurring. So when I do that, I'll just be left with 21. And I've got a nice whole number. That's what we always want to try and find, a whole number. So now simplify this off. I've now got 90x equals 21. X equals 21 over 90. So now let's just simplify this. Well, 3 will go into top and the numerator and denominator. So that will be 30 and 7. And that won't simplify anymore. So now I've got x equals 7 over 30. So that's my final answer for that one. Now, what about this one? So, same principle as before. Let's create a number to get this recurring to be the first digit after the decimal. So if I set my x equal to these two numbers here, they are the same. And now let's get this recurring decimal to here. So I'm now going to need to multiply by 100. So 100x equals 58.3 recurring. So now I've got this one here. So now what I want now is another digit on this side, still with a 3 recurring. So now I need to multiply it by 10 again. So 1000x is 583.3 recurring. So now I've got what I want with 2 recurring decimals at the end of these two terms. So now if I subtract them, just like I did on this one, we should get rid of that recurring decimal. So 1000x minus a 100x equals 583.3 recurring minus 58.3 recurring. So that's going to leave me with 525. So that will leave me with a nice whole number. So basically what I've got here is 583.3 recurring minus 58.3 recurring. So they will cancel, and then that's why I'm left with 525. Okay, what we're going to do now is simplify off and then solve for my x. So now I've got 900x equals 525. And now divide both sides by 900. So x equals 525 over 900. And now let's see if I can simplify this off. So 5s will definitely go. So 5s into 900 go 180. 5s into 525 go 105. Now what can I divide by this time? well, I can see 15 actually. 15's into 180 go 12, and 15's into 105 goes 7. So now I'm left with x equals 7 over 12. So that's what my 0.583 recurring is. It's just left as 7 over 12. Okay.